Hello everyone. So it's already 10 in Japanese Standard Time. So we start with the second series of webinars for the second phase. First of all, I want to congratulate all of you for successfully completing the first phase, and I want to introduce one of the BirdSex team members. This is Tasuku Matsui. He is in charge of the backplane board, and he will be giving the webinar today. So Tasuku, please go on.
Okay, hi everyone. Welcome to today's webinar as Jorge introduced me, I'm Tasuku Matsui from Japan. So my role in the BirdSex project is a backplane board. Which works as an interface between the satellite bus and your payload. Before I start this presentation, we have an announcement. So we decided between the last webinar and today that the name of our satellite will be Dragonfly, as written here. So if you pass all selection, your payload will be integrated into the Dragonfly. So we are looking forward to adding the payload to the Dragonfly satellite. Okay, then I start today's webinar. So this webinar is for the participant of the BirdSex project APRS Payload competition who passed the first phase. In this webinar, I'm going to explain what we expect from you at this second phase. So this is the outline for today's webinar. So we have mainly two contents. At first, I'll explain about the application form you need to submit at the beginning of May. This form is composed of several sections, so I'll explain one by one. And after that, I talk about our website information. You can get new information from this website, for example, the antenna patterns or link budget, or etc. So, and then after finish my presentation, we will have time for questions. So you can ask us freely at that time, and you can also ask in the chat box while I'm talking. So feel free to ask us your question. Okay. So this is the timeline of second phase. The second phase was started from the 15th of March, and it will finish the end of May. And the deadline of submission is on the 5th of May. So you need to submit in almost 1 month. And after the deadline, we will evaluate each teams, and then we are going to announce the result of this evaluation and which teams can go to next phase at the end of May. And this is a point allocation for the second phase. So we allocated some points for each section of the application form. So, for example, the 20 points for system block diagram, or 5 points for the below material, something like that. And as you can see, The most important section in this phase is a feasibility study, because we ask you to prove how feasible to make your payload. So that's why we allocate many points for this section. Okay, so in this phase, you need to make your plan to develop your payload more concrete and detailed, because in this phase, we will select the 10 teams who will go to the next phase. So you need to prove how feasible your payload is by the application form. So for this application form, we expect you to describe as many details as possible about your payload. So to do that, you need to develop the breadboard model and do the functional test with that. And additionally, you also need to show what you did to outreach not only this competition, but also APRS, because we would like to promote the APRS. So this is also important things. And finally, you also need to submit the video presentation. We hope you make it easy to image and understand your payload through this video presentation. I'll explain more detail about this presentation. So in this, let's move to the next slide. So as I mentioned, you need to submit the application form and the presentation video. So you need to submit these two things on the 5th of May. So for this presentation video, we have some terms. So at first, please make your presentation material in 15 slides or less. And please finish your presentation video within 10 minutes. And then in this video, please show the face of the speaker and your teammate. You don't need to show up always, but please do that at least once so that we can know who joined our competition. And the presentation video is also the target of evaluation. So please ensure this video's quality is good. Okay, then I'll explain about the application form. For the first section of application form is the system block diagram. In this section, we expect you to show the whole system of your payload. In the previous phase, we asked you to submit a system block diagram also, but at this stage, we ask you for more details and practical one. So for example, if you are going to put some sensors, you need to show each sensor in your diagram and where it will be connected and what kind of connection, so what kind of communication will be used, like SPI or UART or something like that. And you need to show all the main components, including OCP or regulator or something like
Recording
that.
in progress.
But you don't need to show the tiny component like a resistor or capacitor, something like that. And now you will develop the BBM, or maybe you are doing it right now. So you can submit the schematic of your board also. But submitting only a schematic is not allowed. So it means you cannot pass to put the system block diagram. So please be careful. Okay, so and as a caution, in your diagram, please show the specific number. So for example, the parts number of each component, or voltage, or impedance, or communication protocol, or etc. And also, please explain the details of your block diagram so that we can understand it correctly. It means submitting only diagram is not allowed. Okay, so this is an example of a block diagram. Many of you will have some other equipment like sensor or something else. So in that case, please show each component as I mentioned. And also, please put the part number like that, so that we can know what you will use exactly. Please do not put just a general one, like temperature sensor or something like that. Please mention it specifically. And I don't show it here, but you also need to describe this diagram in the text, as I said. Okay, so the next section is a pin assignment. In this section, you need to show the pin assignment of your payload. As you know, your payload will be connected to the satellite bus through the 50-pin connector. So please make it clear the function of each pins. So the power lines and ground lines are the common things for the all subsystem of this satellite. So you don't need to mention about that. And we already published the first version of ICD, as you know. In the ICD, we show the general layout of pin assignment. So you cannot change the layout of this pin assignment. So please be careful. And as in the previous section, please explain with a sentence about the role of each pin in a simple way. So this is an example of the pin assignment table. As I mentioned, you cannot change the layout of pin assignment table. So it means the programming line must come to pin number 1 to 3. And other things, for example, the UART line or DIO line to control the OCP, it must come here. And please follow the layout which we request from you in the ICT. And you need to show the more detail of each pin. So for example, in the below of this table, you can explain the pin number 1 is for the master clear line and pin number 2 is for the PDC, something like that. And as I said, you don't need to mention the power line and the ground lines. So the number 13 to the 16 and 23 to the 26 and 35, 36, 49, 50 is a power line or ground line. So you don't need to mention about that. Okay, so the next section is a bill of material. In this section, please show your bill of material, BOM. We will check all parts that you use for your payload. So please list up all components and please mention the cost in the US dollars and the operation temperature in the Celsius degrees for each part. And you also need to show whether you have already have that component on hand. If you don't have the component yet, please write in red and mention where you will get that component in your hand. And some component cannot be found in the market, and it causes you cannot make your payload. That's why we ask this information, and we want to confirm whether you can really make a payload or not. And as you can see, this is an example of BOM. So as I mentioned, if you don't have the component yet, please mark it up in the red like this, and please show where you will get that component. And in this picture, we just show the 3 components, but please list up all components you will use for your payload, including tiny components like a resistor or capacitor or something like that. Okay, so the next section is a feasibility study. As I mentioned in the previous slide, this section is the most important thing in this phase because we mainly ask you about the concept of payload in the previous phase. However, in this stage, we mainly expect you to prove how real and possible to make your payload. So if you cannot show the feasibility of your payload, we cannot select you even if you have a great idea of payload. Okay, so in this section, you need to mention about power budget and mass and volume and the concept of operation and preliminary link budget. So I will explain them one by one. So as far as for the power section, you need to calculate the power budget of your payload. And to do that, you need to estimate the power budget for each mode. In your payload, you have several modes, like a dissipator mode or your mission mode or something like that. So please mention the power budget for each mode. And for the power budget, you need to measure the power consumption by each component. And you also need to decide how much time you will run this mode to estimate the power budget. So in the power budget table, please mention the operation time also. And this is a power budget table for our satellite. So you don't need to do the same things because this is for the whole system of the satellite. And what you need to do is only for your payload. So this is a different things from what we asked to you. But the concept or layout is the same thing. So you can use this information as a reference. So in the first row here, you can see the maximum power allocated. these values comes from the test result of power consumption. So in your case, you need to measure each component to know this value. And as you can see in the left lines here, this shows the mission mode. So you can make several lines by each mode, and you can show what component will be used for this mode and calculate how much will consume in total. And as a caution, we mentioned the limitation of power consumption in ICD, so please check it and follow the limitation. Okay, then the next section is a mass and volume. In this section, we request you to show the mass and volume of your payload, of course. And you can show the mass information of each component and in total. But some components are too small, like resistor, capacitor, something like that. So you don't need to show the tiny things, but please mention about main component, like a transceiver or something like that, and total mass. So regarding the volume, please show the volume of your payload from at least 2 phases, so that we can know the width and height and the thickness of your board. And you also need to show the path distribution. And to show the volume and path distribution, please make clear the orientation of your board so that we can understand it correctly. And you can put some 3D model or pictures to show these things. And you also need to explain in text, like the previous section, about this information. Okay, so the next section is a concept of operation. In this section, you need to explain your concept of operation. We request you to show this information from in the previous phase, but in this phase, you need to describe one specific one. In other words, please show the flow process from the beginning to the end of operation. You will start as the turned on the MCU by the bus exercise, something like that. And please make it clear what component will do that action and when that process will be done. So for example, when the MCU receives the command, the MCU will activate this component, something like that. And please make this concept operation by each mission mode. And this is an example of distributor mode. So please describe step by step. And this example shows a divided situation, like an activation or a shutdown or something like that. And actually, this example is not full one because you need to consider the interrupted situation. So it means you need to prepare to receive the command while you are doing this beating. So we don't care about the way to show your concept of operation, but please mention all steps to understand what process will be done. We consider the process that is not written here, it cannot be done. So please be careful, and I will say again, please show the whole process of what can be done. And if there's some possibility the process will happen, please mention it with the situation. Okay, the last section of feasibility study is the preliminary link budget. In this section, you need to show the preliminary link budget of your payload, as I said, and the link budget is a critical thing for the communication ability. So it's really important things. To make the link budget, you need to test the capacity of your transceiver, mainly the power output and the sensitivity. Okay, so this is a link budget for uplink. So if you have your own ground station, maybe you can change the value of it here, but you can use the same value for this part. And uplink path, this is also, you can use the same thing. So you don't need to change it, and you can consider this value as a constant, of course, in this form only. And the important things is the sensitivity. So you can see here the sensitivity. So for this value, you need to test and check the sensitivity of your transceiver. So please do that. Okay, so this one is the link budget for the downlink. The most important things is the power output, you can see here. So you need to measure the power output of your transceiver and put the value. And other things, the path and the ground station is the same thing as the uplink one. so you don't need to change it. And you can download this information about the link budget of our satellite from our website. So please check it. Okay, so the next section is the safety compliance. To integrate your payload into our satellite, we ask you to avoid interference, both mechanically and electrically. So in this section, please explain what you will do to avoid interference. For example, to follow the ICD, of course, or use RF sealing, something like that. But please do not mention the general one, but specific and concrete way. Okay, and the next section is also related to the safety compliance, but the next section is isolation system. Your payload must have an isolation system in case of emergency. In your satellite, we will have many payloads from different teams, so that if the satellite fails, it means all teams will lose the opportunity to do experiment in space. So we designed the satellite not to fail, of course. And as a part of this effort, we request you to have an isolation system, avoid failure while you are doing your own experiment, so that we can survive the emergency. So please make it the isolation system and explain about it. And please mention what kind of emergency can happen and how your isolation system will work. Okay, the next slide. So the next section is the schedule. In this section, we request you to show your plan to develop your payload. And at the previous stage, we also asked you for a schedule. But in this stage, please mention as many details as possible. At least, we will ask you to make a schedule as a weekly task. And to make the schedule, you need to list the whole task you need to do for development and decide when you will do that. You also mention whether you did that task or not. We understand that your schedule can be changed after that, but please make a schedule from now and until the end of competition. And make it clear to tell us your development plan. It doesn't matter the form of the schedule. So you can use the table in the application home, or maybe you can use the Gantt chart or something, other things. Okay, so this is an example schedule. So you can list up all tasks, what you need to do, and you can also show when you will do, and what is the deadline of that task. And you can also show that you already did, or maybe you are doing right now, or this task is delayed. So yeah, this is the example, but looks like a Gantt chart, but the form, it doesn't matter. So please show your schedule, what you want. Okay, so the last section of application form is the outreach effort. In this section, we request you to show your outreach, for the effort of outreach. So you can mention what you did from now, and you can also mention what you will do after that. For example, so you can mention about social media activity, or attendance of the conference, or hold the workshop, or something like that. And you can also mention the future plan, of course. Okay, so this is an example. So you can show your outreach activity by picture or something other things. And please explain what you did and what you will do in the text, like the previous section. Okay, from now, the explanation for the application form is finished, and I'll go to the next section. So from now, I talk about our website. On our website, you can see the information of our satellite, like a structure or link budget, as I said, and you can also get the antenna pattern of this satellite. So if you visit our website, you can find this document in the folder of the satellite documents. So if you click here, you can see these documents. So please check this one. And as I said, we are developing the satellite now and testing many things. So these things can be updated. In that case, we will announce the update. So please be careful and please pay attention for our announcement. Okay, The presentation from me is finished. So thank you for listening, and we received the question time. So if you have a question, you can ask now. So please raise your hand. Hello.
Hello, can you?
Hello? All right, can you guys hear me? My question was, how many packets are we required to store? And when will we, or at what point, how many will we have to send back?
Sorry, could you? Sorry, can you repeat the question?
Yeah, sure. My question was, do we know how many packets we're required to store in total when we're in the store and forward mode? Like, what's the data requirement in total?
What is the data requirement of store forward? Okay. You have your microphone.
Okay. About how many, as much as you can store inside the payload, so we can verify how is the performance, how your payload can perform the task of receiving the APRS message. It will be better for the mission.
Okay, thanks.
Miguel, you can go on with your question.
And please, I want to ask about the output power restrictions. Is there any output power restrictions?
Output power restrictions.
Restrictions?
Okay, I can answer your questions. Okay, there's a limitation about the power output. It's about 2 watts at maximum. So that is the limitation that was imposed due to the power consumption we had in the satellite. And also we have the restrictions from the ITU for the ITU frequency coordination. Is that answer your question?
Yeah, thank you.
Okay, you're welcome.
Okay, there is some questions in the chat. The first one is for component naming and schematics. May we assume that standard reference designators that are cross-referenced to the BOM are acceptable? Yes, I think like that is acceptable. As Tasuku said, please just mention it everywhere, like the number of the component in the BOM as well as in the schematics and in the in the schematics and the BOM. The second question is in the time domain, how long will each APRS board be turned on? Is it fixed or it can be negotiable? Right now, we're actually discussing how much time we're going to allocate to each payload. The minimum that we're going to give, or that we decided already to give, is 1 week, but we are still like discussing to extend it. And if there is a requirement, we can talk about it in the future. Then the next one is, do we have an example of isolation practices, procedures, and systems elements that have been used in birds in the past and will be compatible with the current satellite design? Related, does isolation imply fully electrical and mechanical isolation? We don't have an example. I mean, we will release probably an example of the field application form, but as well, we want you to create this isolation situation. So, for example, how can your payload be turned off through a switch, so it doesn't affect anything? Like, and yes, it involves electrical, mechanical, and radio signal, like isolation. Then the next question. The next question is it possible to show use simulations instead of a BBM for specific cases? Could you develop on this question?
Okay. So about your BBM, can you explain with more details about what simulations you want to prefer to send instead the BBN? Because we need the BBN as a demonstrator of the feasibility of your payload.
Sorry, we can't hear you. I think you have mute yourself. Or mute yourself, we can't hear you.
Okay. So so about the questions, the last one that I stopped is it possible to simulations? I think Javier answered to that question. The maximum temperature considered to the APRS, there's some components and we need to have a standard for space graded components. So the temperature, I think, is in the ICD. About the schematics and the block diagram, yes, it's a good suggestion, and that's exactly what we want. So we want a list of all the important components, part numbers, as well as in the VOM, so we can see how feasible is this payload or all the components to get them. Then there is a question that no PCB manufacturing files are needed at this phase. No, in this moment, we just need a proof of concept. So basically a BBM. For manufacturing, it will come in the next stage. That is when we will ask for the EM and the FM board. Then, Javi, could you say, please, the approximate operating frequency of the APRS devices?
Okay. The frequency of operation of the APRS payload is 145.825 megahertz, and this is the frequency operation. It's the same frequency operation of the APRS of the ISS. So it's important to check in the ICD. There is also the information about the frequency of operation of the APRS and also the power output limitation.
Okay, so the next question, can I explain the task of isolation? So, as I mentioned, you need to, in your payload, you need to have some isolation system for the emergency. So, what you need to do is, at first you need to, you need to add the function of isolation. So, at first you need to consider what you can do for your payload, and please please explain what you will do to isolate. For example, so while you are doing your own emission, and if there is some emergency, for example, some emergency can happen on your payload, we would like to shut down the connection to your payload and the satellite bus to survive this emergency. So that's why we asked this one. So let's say, is it okay for answering? Maybe.
The next question is about the antenna specifications that will be integrated with the payload. We will use the same antenna that we used in the previous various missions. So it's considered, if you want to make a calculation about the gain of the antenna, please consider about 2 dBi as a maximum gain. So that, and also we have in the website the antenna pattern. So if that is useful for you, please use that information for your development.
Okay, for the
Okay,
next.
next question for overcurrent protection example. As you show from the system block diagram, we need our requirement 2 switches. That's like controlling the power lines 5 voltage and 3.3 voltage. So we need it to be LTC4361, this one, or the equivalent from the datasheet. You can download the datasheet and check all the specification of it. So maybe you could choose this one or the other one that equivalent for it. Thank you.
So the next question is either, is it acceptable to show the equivalent cost in US dollars based on the exchange rate? Yeah. So you mean, oh, sorry.
No. It's acceptable.
Yes, it's okay. So if we can understand the cost in US dollars, it doesn't matter. So it's okay.
Yes.
So the next question is when not in transmit mode, we keep alive power, or does the load need to be 100% turned off when it is not turned on?
So when your payload is not working, it basically will be completely turned off. So it's 100% turned off when your board is not on turn. Then there is some questions.
About which one?
Mute. Question 1 is required radio frequency transmit power, DC 3 watts. It's okay for efficiency?
Okay, to answer the questions, I think in the ICD was very clear that the limit power output is 2 watts. So just consider that the power output, the maximum power output available for transmission on APRS, and the required sensitivity. Yes.
For the first question, I'm asking, yes, the power for DC is 3 watts, it's okay, but there is a required efficiency or not? This is a question.
Okay, this is about the power, energy power. As I see here is the RF transmit power. DC 3 watts. Maybe I don't understand, or maybe it's not clear for me.
Okay, for the RF transmitter, this is between 1 watt to 2 watt. Yeah.
Yes, exactly.
Okay, for the DC, the maximum one, as I said with the ICD, the documentation, they said the maximum is 3 watt. Okay, but the efficiency there is a required efficiency, or this is depend on the team.
Okay, so maybe we need to update that information so to provide you the efficiency required. But we will take that in consideration. So thank you for your question. And about the sensitivity required, as you can see in the link budget, there is a There's a value for the sensitivity, but if you can get the most higher sensitivity as possible, it will be better because you will be able to receive more efficiently the transmission coming to the ground stations. So that is my answer. If you can get like less than, it's better than minus 112 dBn, that will be very good. But if at least you can get 100 dBm, it will be good. But anyway, we will update that information so about the required sensitivity based also in our test. So that is the information. Okay. And about the bandwidth, yes, the bandwidth, just consider, please. That is a very good question because consider that your payload will work worldwide. So please check the frequency bandwidth allocated for each region of the ITU. For example, here in Japan, we have about 15 kilohertz of bandwidth on, especially for that frequency for VHF. But in other regions, like the region 2, that the bandwidth is limited to 12.5 kilohertz. So I think you need to check the frequency allocation for every region. So please take the lower number and try to accommodate for that to be success, to not have problems with the frequency coordination. So for the next question about the
frequency deviation also.
It's the lowest possible as possible.
Okay.
And for the question number 3, the period tuning range only for the APRS channel worldwide or continuous between 140. This is the tuning range.
Question number 3, it is about the digimeter transmitter packet timing and the duty cycle in time and delay between the RX and TX.
Okay, digital transmit packet timing. So, okay, we expect that your payload must be prepared to work almost all day. So, please, that is a part that you can send to us. So we will update that information about the cycle time, the delay between the RX and TX. We also will provide that information. But also the delay between RX and TX, normally we use some values, but we need to check again all this in order to provide you based on the previous missions that we have here. So we will update that information.
Okay.
And the next information, carrier tuning range, only for APRS channels worldwide continues between 144.1 and 46 megahertz. So the frequency is fixed. So please don't try to change the frequency. Just we're gonna use the 145.825 megahertz. That is a frequency used worldwide. So prepare your payload for that frequency. And the received packet
145, sorry,
145.825 megahertz is the same frequency of the International Space Station, and also that frequency is in the ICD.
Okay.
And
145.85.
145.825.
825. Okay.
Yes. Okay. Question number 5 about the received packet storage, RAM or flash memory, volatile or not, maximal size. So, as I answered before, as much message that you can storage in the flash memory, that will be good because we can have enough proof that you can we can have enough data that about how is the performance of your APRS payload. And the number 6, you are 9,600 BPS, TTL 5 volts or 3.3 polarity format. That is all these questions about the question number 6 is are very clearly explained on the ICD. So please check again the ICD, and if you have some questions, more detailed question about that, we are available to answer. But this information about the communication between the the mission box and also the payloads are very clear in the ICD.
Okay, thank you.
You're welcome.
So the next question is there an ADCS system on the satellite? No, we do not have any passive or active ADCS on the satellite. We decided since the beginning it was not necessary for our mission, since it's the satellite tumbling would be actually better for us and for the antenna. So we decided not to add any ADCS on the satellite. And then there's a question about RF operations. Is there a spectral mass that is different than what is mandated by regulatory authorities? That is for the satellite itself. Are there upper limits defined across a specific band of frequencies, or are we expected to be only as good as required by the standard licensing in the APRS band? Okay.
So as I told you before, in the frequency that we're gonna operate is really is used worldwide by the amateur radio community. So we are applying for the frequency coordination, and also during this process we need to follow all the rules that is are mandatory for especially for the IRU. There is the International Amateur Radio Union and they also act as a link between the IRU and the amateur radio community and the ITU, that is the International Telecommunications Union. So as I told you before, please concentrate in the frequency that I have mentioned before, and also the bandwidth. Take care about the bandwidth, especially considering the region, the frequency allocation for every region on the ITU, and specifically take the lowest bandwidth as possible in order to not have any inconvenience during the frequency coordination.
I guess my question, just to clarify my question, because we don't know what else is operating, I mean, obviously we don't know the other payloads from the other teams, but for birds, you know, I'm thinking of local frequencies. You've got, say, DC-DC converters, and, you know, we've got tones or spurs that are out at certain frequency. Is there anything that you're specifically worried about on the main bus that is sensitive to harmonics and things like that?
Okay. Specifically is because I think is your point is more about the protection, the RF protection that we need on the payloads. Can you, is that clear?
That's partly it. Yeah.
Yes. Okay. We need that protection because we need to put a shielding on the RF and or every component that generates RF, because we want to those components cannot affect the sensitivity of the payloads. So it's a measure that we request to protect also your payload and the other's payload. So we don't want that for one payload is activated can cause an interference and in this can cause an RF interference also, not only in the other payloads, but also in the communication system of the satellite. That is the reason that we request about the protection for the RFI specifically.
Right. Okay. I guess maybe to anticipate it is just we should have good practices for EMC then.
Yes. Yes.
Okay.
Exactly. Thank you.
Okay, for the next question is in the isolation system means, are you expecting a killing mass mechanism? Yes, for this answer, yes, the answer is yes. So as you can see this diagram, so the power line is the switch is controlled by our mission bus X project site. So your mission MCU doesn't have the way to control the switch. So it means you cannot kill yourself, right? So we expect you to disconnect exactly. So that's why we ask this isolation system. So is this clear? Okay, maybe we can move to the next question.
Yes, it's clear.
Yes, thank you. Next question is, does the main power supply have the ability to isolate from the payload or will it disconnect the rays? So even if the data on the power to apply, you can do. Me? So this means we have the physical disconnection. I mean, is it correct? So for answer this question, so yeah, as you can see, we have the switch to disconnect the power supply, both line, but we don't have how to say the rail. We don't have the physical one. To say, so.
Okay, so to be clear, when the DIOs
Okay,
disable.
for that questions, we have here 50
This is asking.
Sorry.
Can you continue?
Yeah.
Could you continue with the question? Sorry.
Oh, just to be clear, the DIOs will activate, for example, the LTC 4361, which will isolate or basically effectively isolate the local payload board that say we provide, but there'll still be a live rail to the board edge, right? And to the chip. So, is there the ability to completely isolate the board from the rails? So if you determined that there was still a current draw, for example, if you turned off our board and there was still an unwanted current draw, you had one more mechanism.
For the
or
power
we-
lines, we will be connected. Okay. Nice. Okay, now. Okay, sorry, because we have some problems, guys, for that interruptions. It's okay. For this lines, we have here 50 pin connector. So all the power will be supplied for all the APRS payloads through the 50 pin connectors, and all APRS payloads will be connected through the backplane port. So we don't we have here for turn it on the APRS payload, it will not be turned on until the switch is turned on. So it means there's no power for APRS payload until the over current protection switch turned on. And that's answer for your APRS payload. Please tell me if it's clear or not.
Okay, so you're saying you have overcurrent and maybe over voltage outside of the payloads.
Yeah, we have the same also. From our side, we just asking for over current protections, but as you need to distribute all the power from your side, you need a DC-DC converter and so on. But for our side, we will supply you with 2 power lines. So we need you to tell us which power lines you need according to your requirements, if you need 5 voltage or 3.3 voltage or both of them. But for DC-DC converter, that's according to your design.
No, I'm not talking about DC-DC converters. I'm talking about physical isolation on the payload board. So if we want to isolate from the main bus 5 volt and 3.3 volt lines, do we have to do that? We have, a device, the LTC, for example, 4361, but do you want us to physically open that circuit that's on the left side of the LTC in this block diagram?
Yes.
So he mean
Yes.
what? Yes.
So to answer the previous questions, yes, it's correct. Like this connection will be through these OCPs. And the next question, if it's okay, like we continue with the questions. Are we allowed to place components on the rear side if it doesn't interfere with the other boards? No, you're not allowed. We're just allowing on the front of the board. Why? Is because we have a maximum of volume right now. And to avoid all this interference and all the changes that we need to make, if you put components on both sides of the boards, we're just allowing you to put on one side. So as you remember from the previous webinars, in the ICD, we allocated 13.6 millimeters from as maximum height of the board. So if you are in between these set parameters, like it's okay, but you cannot put from the other side of the board.
Can you, sorry, can you elaborate on that? Because the physical drawing shows the connector going well below the backside of the board. And we were simply wondering about things like decoupling capacitors, for example, at a low profile that would be well underneath that connector's maximum height. So that's why we ask.
Okay, I meto what we're planning right now is just, we decided like just one phase would be, how to say, used. We understand that the 15 pin connector goes, how to say, as you say, way, how to say, deeper than on the back side of the board. But apart from that, we're not planning on it because the distance that we have right now is kind of very limited. So, right now we decided that it's only on one phase. Maybe in the future, like since we're still developing the satellite and we're still like allocating, how to say, the positions of the boards. So maybe in the future we'll be able to get more space, or maybe we'll make an update on the ICD to if we let you put components on the back of the board. But right now, and as it seems, how is it going? We're not going to let it. So we're just going to let components on one side.
Okay, fair enough. Would it be okay to show, just to demonstrate an alternate design that would not be our main submission, but we could give you our concept as a 3D model, for example, in the submission for consideration, not for this competition, but for future.
Yes. I think that is completely fair. And how to say, if you send a design that, like, how to say, we expect everyone to comply with the fact of that we have a limited space and we have limited time, so we won't be able to give everyone time if they give us special designs, right? But if you send it, like, we can surely discuss it.
Yeah, because we would like to use this to build, further designs that we may fly ourselves. In various places, right?
No, I completely understand, and that will be okay for us. Yeah.
Okay, thank you.
Yes. Are all payloads required to have a sleep mode?
So for this question, I think you don't have to have the sleep mode because your payload, when your payload doesn't work, your payload, how to say, when other payload will work, your payload will be turned off, of course. So if you need to have the sleep mode, maybe you can implement it, but we don't request you to have the sleep mode. So you can choose to mount or not. Is it okay? So maybe the next question is, why does the TNC need to have its call sign change? So can Javier ask this question?
Okay, about why does the TNC needs to have its call sign change? Okay, it's a very important question because in the first phase, we require, for example, that you have your all call signs. That is for testing purposes. But we request that your TNC can be able to change the call sign because the satellite is considered legally as a repeater, that is a repeater that will be registered in Japan, but will be operated in the space. So it's like a ground repeater we have as for amateur radio, but in this case, instead to be on ground, will be on the space. So it's that for that reason and for legal reasons, the satellite must be registered in Japan, and also that requires that all the transceivers inside the satellite must have the same call sign of the satellite. But we will add another capacity in the satellite to let you know when your payload is activated, so you will know in some way we will provide you that way that you will know when your payload is working, so you can communicate with your payload by APRS message. So you can send all the message, but the payload call sign will be the same of the satellite. It's for legal reasons that we decide to request that the TNC must to have the call sign must to be. We need to change the call sign of the TNC of the payloads. So that is the answer about that. So thank you.
Okay, so for the next question is, are there consequences for adding or changing the scope of the payload experiment since the phase 1 submission, if we come with a more interesting or relevant payload? Right now, there is no consequences for changing the scope of the payload since the first one was just an idea, right? Like, of course, if you change completely, like it's something completely new, but just keep into consideration that after phase 2, there will be no changes into the scope or any type of a component of the payload. So what you decide in this phase and what you submit for this phase will be the final version, the final idea for the final version of your payload. So take that into consideration. So I'm not sure if we actually answered to all the questions. If there's any more questions, please tell us. So please, this is the perfect moment for ask as many questions as you want, because for us it's hard to answer immediately to all the mails that we can receive. So. There's one.
In what case we need to send packet to the mission bus? Okay. So for example, if you are if you are MCU and how to say find the some irregular and you want if you judge you need to how to say shut down your payload, you need to send this situation to the mission boss and if the mission boss receive this how to say this acknowledgement, so mission boss will send the OBC and the OBC will send back to the shutdown of your payload. So in what case, so if you need to shut down your payload, you need to send the request to mission boss cut down. But mainly we will allocate several times. So if the you pass the specific time, we will turn off your payload automatically, I think. So it is clear.
Yeah, that's good.
Okay, thank you. When will we get more info about the API required? So you mean the programming line, I think. So in the first version of ICD, we already defined that you can use the 3 lines for programming to program your MCU. And so what kind of information you ask to?
I guess I'm looking for more, like what commands exactly does a mission boss need to be able to send to our MCU? Like what's the scope of the control it requires, and like what's the format of the data it needs to get back, stuff like that.
Okay, so please give me a second. So you mean you mean you want to know about the command, what kind of command will be sent from the mission boss, is it correct?
Yeah. And also what data format the mission boss requires in return?
Okay, so basically the command for the mission boss for the APRS board is we developed based on the bus5 one. So you can know the command format from the open source of bus5 one, but we just modified a little bit. So we will announce when we completed to make the command list. But for the APRS, our command we made we are going to use the same command from the bus5 one. So you can know what kind of command will be sent from the mission boss. But for your own mission mode, we didn't know what kind of mission will be done. So we cannot make the whole command to. Sorry.
Can I explain a little bit clear? To add that Suko says, that is a very good explanation also. Okay, what we need from the payload, we need that you can provide us how to access to the flash memory in order to we can through the OBC we can send the commands to the mission boss in order to get that data that is storage. The APRS message is storage in the flash memory. In order that what is the purpose of that? Since we want to evaluate how is the performance of your APRS payload, we need to have the access to to the flash memory of the payload, so we can retrieve that data and also transfer to the other memories on the satellite. And in the final purpose is to download that information in our ground station, so we can check the performance of your APRS payload, and also you can get that information and you can know how good is your payload. That is the purpose. We need that you can provide us how to access to the flash memory, how to turn on your payload, how to turn off your payload. That is we are requesting for you. Is answer this question or is clear?
Yeah, that's cool. That's clear. Thank you.
Okay, you're welcome.
So is there any question?
Okay,
Hello, I
so
have a question.
Sorry, I have one more question. So you said for the phase 2 application, it's sort of based on feasibility of the design and proof of operation. And then after phase 2, like into phase 3, it's just if you can deliver the product, right? If you can deliver the board, then like there's no extra, or like everybody who passes phase 2 goes into phase 3, correct?
Everybody who passes phase 2, I mean, we accept after this phase, we accept 10 teams, and after 10 teams, they will provide us with the EM board. We will test the EM board. So basically, the phase 3 is just a technical phase to select and how to say make all these technical tests that we need to make here in QTech for like integration and all these type of tests that we make. And we will select the best payloads from there. We will select the 5 best payloads from the 10 selected ones. So in this phase, yes, like, I mean, right now it's just feasibility. Then after it will be like technical, how to say, well, technical tests, let's say. So a technical phase, you could call it like phase 3.
So, and then for that phase 3, so we're going to give you boards and you're going to test them, but those aren't the FMs though. Those are just like EMs.
Yes, they're the EMs. So the test will be made on the EMs, and after like when selected the best 5 EMs, we will ask for the FMs. So that will be already the final. That is already not a phase. That is already the final. Let's say 5 or 6 boards that we will select. They will send the FMs, and the same tests that were conducted on the engineering model will be conducted on the if in the flight model, but already like with the final satellite, like just for integration.
Sure. And I guess not to get too ahead of myself, but is there a standard procedure that you guys have set for shipping boards internationally?
Yeah, we will provide all these documents and how to ship all these all these procedures by the end of this phase. So as we said in the first phase, the ICD and all the documents that you will be needing, let's suppose in the process, we will be provided with time. So right now, like we don't have them, but like we will update, let's say the ICD, and you will get these documents for sure when it's necessary.
Sure. And the technical testing, does that include the mechanical testing like TVAC or vibration?
Yes, it will include vacuum testing, thermal vacuum testing, and vibration testing.
Okay.
And all of these tests are done in Tech, or
All this testing, I mean, the only test that we ask for you is about the antenna testing, let's suppose the radio frequency testing in your countries. All the environmental testing will be done here at QTech.
okay.
So are you okay if we do our own mechanical environmental testing though? That's the question.
We have no limitation on that. How to say? I mean, we ask participants to make only the radio frequency testing, let's say all these experiments, because we understand that not for everybody is possible to have like the testing facilities that we have here in QTech. So we don't have a limitation. If you want to make your own tests, then you can send us like, and we will make basically the same. So yeah, it's possible.
Would you be able to give us the specifications for the mechanical testing, the shake and vibe, so that we matched what's required by the space agency?
Yes. When we have a launcher, and right now we haven't decided which launcher like we will use, but all the specifications on the launcher, on the vibrations, the random vibrations, all of these, we will get them, and this information will be public. So yeah.
Okay, thank you.
Yes.
For the third phase, are we also going to have like webinars and information provided?
For what?
For phase 3, because
yes.
In phase 3 we are going to basically be evaluated based on the technical stuff that we're going to have, the technical parts. So okay, thanks.
So as we said in phase 1, we plan to constantly be in contact with you. Right now, like for you to understand, you're part of our satellite, a very important part of satellite. 70% of our satellite is going to be your boards. So how to say, by this phase, there is more than 20 teams, but next phase is going to be 10 teams, less people. And by the time that we're like selected for the phase 3, let's say like it's going to be 5 teams. So we're going to be in very close contact. And as we mentioned in the first webinar, we hope that like at some point, one of the prizes, let's say for all this competition is that one person from your team can come here to integrate your board with our satellite and maybe make the testing with us. So yeah, we'll be in contact. We'll have like constantly webinars as we're having right now, and the ICD will be constantly updated. So yes. Okay, so if there is not any more questions, I think we can finish now this webinar.
Oh, one last question.
Yeah, please.
Let's say if my team, for example, gets to be one of the selected teams, one of the 5, are we expected to represent one specific university or organization? Because in our team, we are 6 people, but 4 of them are from a different country and a different university, and 2 of us are from a different country and different university. But all of us are part of one organization, but it's a non-profit organization. So I was just wondering if we were expecting to be like to have a representative of like a university or something like that.
I mean, who you represent is your decision. We were just asking in phase 1 for the MOU. So we need to have somebody legally responsible for this. So I mean, who do you represent at the end is we don't have like some limitation on that. Just for the things that we need to sign, the legal things that we need to sign, we ask for like an association or one university. And if the university is okay that they sign this document and they are not mentioned, it's also okay for us.
Okay, perfect then. Okay, that answers my question. Thank you.
Yes. Is there any other question? Well, if not, then thank you. We will announce the next webinar for this phase. We'll have another webinar for this phase in the next weeks. So please keep up with the social media, and any document that you want to find is already on the website, and we will constantly post it. So thank you for coming today, and we wish you good luck in this phase. Thank you. Goodbye.
Goodbye.
Goodbye. Thank you.
Thank you. Goodbye.
Okay.